Hello and welcome. You see this tracing every single day, right? In your books, in the hospital. But what if I told you that the key to understanding it isn't in those famous waves you've memorized? What if the real secret, the clue to a life or death emergency, is hiding in the empty spaces you've been trained to ignore?
Look, you've memorized the alphabet of the heart. P, Q, R, S, T. Great, but that's kind of like knowing the letters A, B, and C without knowing how to actually read. The real story, the diagnosis, is written on this grid. That background paper isn't just decoration, it's the scale, the ruler that turns these squiggles into actual science.
So here's my promise to you. Forget all the complicated math. In the next few minutes, I'm going to give you two and only two magic numbers. That's it. And with them, you'll be able to measure any ECG with total confidence and spot danger in seconds. Sound good? Okay, let's get into it. First things first, we need a little mindset shift. We have to stop seeing this as just a piece of paper. I want you to start thinking of it as a precision matrix, a grid, where every single line means something fixed, something that never ever changes. And it's all built on one single unbreakable rule.
Here it is. This is the foundation of everything. The machine pulls this paper through at exactly 25 millimeters per second, every single time, on every machine anywhere in the world. This speed is our universal constant. It's how we translate distance on paper into time inside the heart.
Now, because of that constant speed, all the complex, intimidating physiology of the heart's electrical system can be boiled down to two incredibly simple numbers. I'm not kidding. These are the only two numbers you need to burn into your memory. They're the keys to mastering time. And here's the first one. Look really close at the tiniest square on that grid, just 1 millimeter across. The time it takes for the needle to draw a line across that tiny little box is precisely 0.04 seconds. This is our fundamental unit, the single atom of time on an ECG. Now, from that one little atom, we can build everything else. You'll notice the grid has darker lines that make up bigger boxes, right? Well, if you count, each big box is 5 small boxes wide. The math couldn't be easier. 5 of those little squares times 0.04 seconds each gives us our second magic number, 0.20 seconds. So let's just let that sink in. 0.04 seconds for a small box and 0.20 seconds for a big one. That's it. That is the entire secret. If you know these two numbers, you can measure any interval and instantly know what it means. Okay, I get it. Numbers can feel a little dry and abstract. So to make this really stick, we're going to use a really powerful analogy. From this moment on, you're not looking at a medical tracing anymore. You're looking at a piece of sheet music. Just look at it this way. The heart is the composer, and the ECG is its musical score. The horizontal axis, the one we just measured, that's the tempo. It tells us how fast the electrical notes are being played. And the vertical axis, how high the waves go, that's the volume, the amplitude. It tells us how loud the heart's electrical song is. And this makes tempo so easy to understand. A healthy QRS is sharp, it's narrow, it's like a crisp, fast note, perfect timing. But when that QRS gets wide and clumsy, well, the tempo is dragging. The electricity is getting stuck somewhere, which is exactly what happens in a bundle branch block. And here's the volume. When the waves are super tall, it's like the heart turned its amplifier up to 11. That muscle is too big, too thick. We call that hypertrophy. On the flip side, if all the waves are tiny, it's like the music is muffled. Something's blocking the sound, maybe a dangerous amount of fluid around the heart, which we call a pericardial effusion. Okay, so now that we understand the music, we have to learn the rules of the song. You know, every good composition has rules about timing. For the heart, these are our critical safety limits. So let's use our two magic numbers to define them. All right, rule number 1 is about the PR interval, that little pause before the big beat. It has to be less than 0.20 seconds. The visual rule is dead simple. It must fit inside one large square. If it's wider than that, the signal is getting delayed, and you're looking at a first-degree AV block. Rule number 2 is for the main event, the QRS. This beat has to be fast, sharp, and efficient. The absolute speed limit here is 0.12 seconds. So how do we see that on the grid? Well, remember our first magic number was 0.04. 3 of those little squares is 0.12. So your QRS has to be narrower than 3 small squares. Any wider, and it's abnormal, period. All right, enough theory. Let's put this into practice. This is where the magic happens. We're going to stop being students and start being clinicians right here, right now. Let's measure a real ECG together.
Okay, take a look at this tracing. Your gut, your clinical intuition might be telling you that QRS looks a little wide, right? A bit chunky. But our gut doesn't make a diagnosis. We need hard numbers. So let's zoom in and get a precise measurement.
Okay, count the small squares with me. From the very start of the QRS to the very end, we've got 1, 2, 3, and yeah, about half of a fourth square. So that's 3.5 small squares. Now for the easy part. We take 3.5 and multiply it by our first magic number, 0.04. That gives us 0.14 seconds. And now for the moment of truth. Our measurement is 0.14 seconds. What was our safety limit? It was less than 0.12 seconds. Well, 0.14 is bigger than 0.12. The conclusion is inescapable, and it's based on fact, not a guess. This is a wide QRS.
And just like that, you did it. You just performed a crucial diagnostic step. By simply counting a few tiny boxes and doing one little piece of math, you have objectively proven there is a dangerous electrical delay happening in the ventricles. You found strong evidence for a bundle branch block. You didn't just see the music, you read it.
So let's just pause for a second and appreciate what you've just done. This isn't just some neat little trick. You have just laid the single most important foundation for interpreting every ECG you will ever see. You can now speak the language of the grid. We started with what looked like a chaotic, mysterious line, but in just a few minutes, we've turned it into a logical, readable, musical score with clear rules for tempo and volume. You now have the grammar and the vocabulary to read the heart story for yourself.
Let's lock this in so you never forget it. First, the grid is a precision matrix, all because of that constant speed. Second, the rules are just two magic numbers, 0.04 and 0.20. Third, the ECG is a musical score with tempo and volume. And finally, and most importantly, your count is what leads you to the diagnosis.
You now have the fundamental skill to analyze any rhythm you see. Seriously. Everything else, spotting a heart attack, finding the axis, figuring out complex arrhythmias, it all builds on this foundation of timing. You've mastered the heart's tempo. So I'm curious, what's the one ECG topic that still intimidates you? Let me know in the comments below.